welcome to the fourth and unfortunately final week of Tesena Fest 2021. My name is Phil. I'm a software tester, not a conference moderator, so please forgive my mistakes. And I'm happy to be here today because we're going to talk about the future of testing. And this is a subject that I'm extremely interested in myself. So I'm really looking forward to today's speakers. First up, we have Mesut, then we have Filip, and the final speaker today is I have to find my piece of paper now. Kohsuke. Thank you, Danny, for the pronunciation tips. Okay, so now I just want to mention a few things. We are using for questions Slido. You'll find a link somewhere above or below the live stream. We'd really like your feedback. Every year we try and make Tesena Fest a little bit better. And next year we would like to make it even better and hopefully in person, if possible. I would prefer that. I'm sure a lot of people would do. So please, there's also a link on the live stream to give us feedback. And since you're on the live stream, you can also subscribe there for our YouTube channel. We're posting quite frequently new content. If you're following our regular webinars, you know that we're producing quite a lot of content, a lot of interesting material. We have lots of interesting speakers and topics, and we're posting that regularly on our YouTube channel. So please subscribe and follow the content. And now I'm just going to launch this PowerPoint presentation, which I hope today is with sound. Okay, so hopefully that was with sound this time. So I'd like to welcome to the main stage Mesut. Mesut, if you'd like to get ready, you're going to talk about the evolution and future of software testing. So Mesut, if you'd like to share your presentation, and I hand over the stage to you.
Yeah, sure. Thanks so much. Let me try to share my screen. Okay. Yeah, hello and welcome everyone. I guess I should say good afternoon because for most of the audience, it should be the case. But for me, for example, it's a little bit late. I'm attending from Japan. I'm in Tokyo and it is almost night over here. But I'm attending to Tesena Fest conferences for maybe 3 years. And it is a great pleasure to be here. And in this session, I want to talk to you about the evolution of software testing, which is the modifications and the changes that we see in our life cycles and the workflows that we are performing in software testing activities. So we will observe different changes and modifications that we have done, and somehow they are applied in our workflows. And we will discuss the outcomes of these changes and the modifications. And finally, at the end of the presentation, we will talk about a little bit more concentrated on the future of software testing. But first of all, let me briefly introduce myself. This is Mesut, and as I told, I'm currently located and working in Tokyo, Japan. I'm working for Rapid Robotics, and I'm a QA engineer working in this field for 12 years. And I'm trying to automate test cases. I'm trying to implement them and perform the automation activities. And then we are trying to run in our CI/CD pipelines, CI/CD jobs. We have some scheduled jobs. And after each commit, we are running our tests or pipelines, which means we try to ensure the new changes or the new development activities do not break anything which were already implemented. So we are somehow trying to do the continuous testing activities as well. So here you can find some contact channels for me. Please do not hesitate to reach out or just feel free to get connected. And this is the brief agenda. As I told in the beginning, we will observe lots of modifications that we are seeing, observing, and we witness in software testing life cycles and the workflows. So we will start from yesterday, which means what we were doing in the past. And then we will discuss what we are doing now. I mean, from what condition to which phase, or in what way did it change, we will discuss. And finally, what we can do more. Furthermore, how we can improve our life cycles and our efficiency, we will discuss. In what ways, in what manners can it be possible to do even more? Because it is currently really very challenging, and we try to succeed more and more. So in the future, how can it be possible in a way doing all these activities in a more efficient way or in a more consistent way? We will discuss at the end of the presentation. We are talking about some changes and modifications, the transformations. But why? Why are we talking about this? Because normally, why don't we find the optimum solution for us and then continue forever in this configuration? Because it doesn't work like that. Because the technology is growing very fast, and the environments, the products, the systems that we are using are changing frequently and very fast. That's why we have to be agile and we have to be responding very fast to these need to changes, and we have to improve ourselves, which means improve our life cycles and the way that we perform. So we have lots of challenges, like time is very precious. Everyone is trying to be the first in the software market, and we try to implement and develop our products in a very limited time, very short time. And after the development activities are done, we have a very limited time to perform our testing activities. So time is precious, scope is very wide. For example, the systems that we are testing, the systems under test, are very comprehensive. For example, they have lots of integrations to the other platforms. So we are testing lots of integrations and interfaces, and we have to do that in a very limited testing window. So these are the challenges. So it looks like really tough and difficult to achieve. But this is why we try to force ourselves to improve more and more. Whenever we have some challenges, we search for some new adaptations, new solutions, and then make some POCs and observe the results if it fits into our life cycle or not, and decide to make some modifications in the way that we perform our activities. So we have some transformations. And if we observe or if we review the history of the quality assurance activities, it started with some simple inspection activities, and in time there were lots of different improvements, and currently we have lots of different approaches, most of them raised from Japan in the automation industry or some other fields. But we are observing every time some new approaches and some new adaptations, and especially concentrated on the software testing, we see that we replaced some old approaches with the new ones, with novel approaches. Like we replaced our manual testing activities mostly with the automation activities. Currently, most of the people, most of the companies rely on the automation activities, and we can barely see waterfall approaches right now. Most of them are already replaced with the agile approaches, either maybe Scrum sprints or Kanban or any other agile approach. But seeing waterfall approaches or management style is not very common right now. And finally, we can see that we have continuous testing activities and some DevOps and continuous integration, continuous deployment, continuous development activities. And instead of big releases, we have these continuous testing activities more and more. So these are the transformations that we already see in our processes. So let's discuss what are the advantages of them, each of them, start discussing them one by one. We will see the outcome of them. I mean, what advantage did we get from them? And on the other way, what difficulties did they raise as a new challenge for us? So let's start with the first one, the replacement of the manual activities with the automated testing activities. Currently, if we see the results of some surveys, we can see that most of the companies already try to perform lots of activities in the automated manner. Because why? The manual effort means extra cost, like extra time, because the human beings cannot run the test cases as fast as the machines, because parallel execution is possible. When we automate or implement our test code, we can start lots of different virtual machines and we can let them run parallelly. So it is very fast when we compare to manual testing. And of course, maybe sometimes we have some stability issues, but most of the time it is reliable. I mean, for example, when we perform or when we execute manually, we follow the test steps which were already defined. But as human, we may do some mistakes. I mean, we may overlook some test steps, or maybe we can discard some weaknesses in the product. But if it is developed and implemented in the proper way, the test code catches those weaknesses. So automation really reduces the human effort and waste of time in a significant manner. But of course, it is not the silver bullet, which means when we automate everything, then the QA team can just disappear and all the things that they can do finish. No, it doesn't mean that. It is not that easy. We have still a lot of maintenance efforts and maybe refactoring efforts, some fixed activities on the test automation framework, because again, most of the behaviors that the test cases are covering are changing in time. So it is not only implement the test case and it will be there in the same way forever. It doesn't work like that most of the time. We have to update our test cases according to the changing behaviors as well. Or maybe we have to improve test framework as well in time by some refactoring activities. But apart from them, there are some risks in the automation framework as well. For example, we may have some situations like silent horror cases in our test automation framework, or we may have some false alarms, which means, for example, if my test case is failing and I'm getting a failure report, failure alarm from my test results, in the situation that the feature is working properly, it is working as expected, but somehow my test case is failing. It means it is a false alarm because it is not a real bug. Normally the feature is working as expected. It is working properly, but I'm getting an alarm. So it is a false alarm, which means I have to understand why it is failing. I have to, first of all, I have to analyze if it is a real bug or a false alarm, because whenever I get some failure, it may have been really a real bug as well. So first of all, I have to analyze the root cause analysis I have to perform, and then I have to understand the cause of the failure if it is a false alarm. Or on the other way, on the other hand, if it is a real bug, then I have to still report the issue in the proper way by analyzing all the aspects. And on the other hand, if there is some weaknesses or vulnerabilities in the feature, in the product, but if somehow my test case passes and does not catch this issue, this bug in the product, then this is the silent horror case. I have a risk, I have some vulnerability, but my test case does not able to catch it. So this is the silent horror case. This will result in some escape bugs, which means those bugs are not caught in time in the development activities or in the testing activities, but it will be shipped to the customer. It will be delivered to the customer, and most probably it will be reported by them. So it is not a desired situation because it results in some extra cost and of course escape bugs we don't want, because when the running code is already in the production environment, then it would be much more difficult to apply our fix because we did not catch that in time. So now maybe it will be really very difficult to change the running code in production environment. So there may be lots of different root causes to have these smells in the automation framework. We have a lot of different groups of test smells we may have. So we have to be really aware of these kind of test smells that can appear in our automation framework. For example, we may have some flaky test cases. Maybe they will pass one time and they will fail in the next run. So this means we have some flakiness in our framework. Or maybe some other test cases are fragile. If we change the parameters, then they will start to fail. Or some scope-related issues we may have, which may result in, again, these kind of issues like the silent horror cases or the false alarms. So there are a lot of possible root causes for test smells, and which can result in some critical consequences in our executions. So this is the challenge of performing the automation activities. We have a lot of advantages that we can get from these activities, but on the other hand, these are the challenges that we have to cope with. So we need really strong quality gates. If we let all these weaknesses in the test code to be merged in our pipelines, then they will be risks for us, which can make some trouble in the future. So in the first place, we should block them thanks to our quality gates and our quality checks. And if we find any vulnerability or potential risks, we should block them in the first place. The second transformation that we have observed in our life cycles, in our quality activities, is the replacement of waterfall approaches with the agile approaches. Again, it is great, because what were we doing in the waterfall style? We were spending a lot of time to define our requirements and then reviewing them, analyzing them, and finally a lot of time for the development activities to design the product, and finally the testing activities. So when we start testing, it was already maybe 1 year, 2 years later, then we start the project. So it is too late. For example, if customer is not happy or is not satisfied with the behavior that the product has, then we will start from scratch. We will change the behavior, we will change the requirement specification, and then change the design, which is very difficult because the architecture is already there. But in waterfall, we run very small sprints, and it is very fast to get some feedback from the customer, because in each one we have some MVPs, minimum viable products, and we can collect some feedbacks and already collect the results from the running code. This is great. This is a big advantage. But now we have another challenge, which is agile is very easy to understand and it does really make sense to perform, but it is at least as difficult as it is easy to understand, to implement it, because we have to be very efficient. We have only 2 weeks. For example, if we are running 2 weeks sprints, or let's say 3 weeks, whatever, but we have a very limited time. And at the end of this time, this duration, we have to reach to a minimum viable product, which can be shipped or which can be delivered to the customer. So it is hard, it is a tough goal. And in order to achieve this, in order to succeed this, we have to be very efficient, and we need a very good communication channel. If all the members in the team or all the cross-functional teams do not talk to each other, then, for example, let's say if the QA team is not aware of what is being developed at that time, then we cannot start our activities in the meantime with the development teams. In order to be able to start right at the same time, I have to be aware what is being already developed. I have to be aware about all the specifications, and I need all this information flow. So we need a really good communication bridge between all the team members and between all the teams as well. And then we need a very good testing strategy, because if we are trying to cover a scope which is not possible to perform at the right time, then I will lose some time. It will be a waste of time. For example, normally we need, as a testing strategy, we need to run the correct scope at the correct time. For this purpose, maybe we need different test levels and different testing priorities. If I lose time to try to perform some tests which is not prior, then I will not be able to run the tests normally which are more prior to the ones that I'm on which I'm losing some time. So my strategy, my way of working should be very efficient, and otherwise I will not be able to achieve the quality goals and achieve to have an MVP at the end of the sprint. And finally, the third transformation that we saw in the chart when we reviewed the history of the software testing life cycles and the software testing activities, the third transformation was the replacement of big releases with the continuous testing activities, because we started to discuss about to where should we shift, right? For example, should we shift our testing activities to left, which means we should do the testing activities as early as possible, or should we shift them to the right, which means maybe we have to focus more on production, on testing on production. And finally, what we decided is maybe we should shift everywhere, which means we should also test as soon as possible. And on the other hand, of course, we should do testing on production as well. So we should test whenever it is possible. So basically, it is the continuous testing. So we start as soon as the development is decided. Some features are already decided by the business team or operations team, and then we have those specifications which are decided to be implemented, and we already start our testing preparations. Like we can start to design our test scenarios, we can already define our test steps, and then if some test data is needed, we can already start to design them and prepare them. This is again a very big advantage that we get from this transformation, because when we have big releases, then I have a testing activity now, and the next one is maybe 3 months later. So I have a very big time, and I can do my preparations very easily. But again, after that big release, we may have lots of major issues, and it will not be easy to fix them in a very short time. But when we perform our continuous testing activities, then it would be possible to detect all the vulnerabilities whenever we perform our test activities. Because when we run test cases, then we will have the results, and some of them will be passing, some of them will be failing. So whenever we have some issues on the product, it would be possible to catch them, because we will have lots of different executions. After each commit, we may start the CI/CD jobs, or we may schedule, for example, for each night. Every night I can execute all my scope, all my test cases, and at the end of the day or in the morning, I can check all the results. But this means it is an additional effort. I have to maintain my test cases. Since I'm continuously running it, if I have any flakiness in my test automation framework, then it will slow down the development activities as well. Because whenever the test fails, then the PR or the branch doesn't pass the checklist, doesn't pass the CI stages, and then it cannot be merged. So having some issues in test automation framework, and whenever we are performing the continuous testing activities, if we somehow are slowing down the development activities, then it means that we have to fix and get rid of this problem. So it means that we have to continuously track all the results and be aware of all the failing tests. And it is not only the results, but there are a lot of metrics that we can collect from our executions. For example, if our executions take a lot of time, then maybe we can track this metric as well. We can monitor the execution duration, and we can measure in time if it is getting even more or less time to execute our scope. So monitoring activities is another challenge which we can do. But of course, again, we can collect a lot of insights from these kind of activities. So these were the major changes or the transformations or the replacements from our old approaches to the novel approaches that we are performing now. But in each of them, as you would realize, there are some big advantages, but on the other hand, there are some maybe we can call drawbacks or maybe some new challenges. So in the second part of the presentation, I want to a little bit more discuss about what we can do more in the future and what kind of other approaches we can integrate in our life cycles or in our processes to make it even more efficient and to even maybe more reduce the manual efforts instead of trying to get rid of some problems manually, how we can fix them in the first place. So at this point, maybe machine learning assistance is a big candidate. We can get some help from the machines. Why? Because they have some certain advantages. For example, like the calculation capacity, or whenever we teach some information to the machine, then it will learn it and it will not forget it. Forgetting is not an issue for machines. It is an issue or it is a problem for us, for human beings. But for machines, if we somehow teach some workflow or some patterns, then it will learn it in the best way and it will make its predictions for the future activities. Whenever a new sample is raised, then it will make the prediction and it will decide for the best result. So we can adapt machine learning activities in all testing stages, starting from the first early stages until the end of our life cycle. Normally, what is an ordinary software testing life cycle composed of? It starts with the analysis of the requirements. And then after we analyze the requirements, we design our test cases to cover all those specifications by the test cases. We try to map the specifications or the requirements by our test cases. And then we do the automation, we implement our code, and we, of course, review the code. We perform some pair review activities. And finally, after it is merged, then we execute them. And at the end of the cycle, at the end of the life cycle, we make our maintenance efforts. So in each this stage, we somehow can adapt machine learning activities into these stages. So we will discuss one by one what we can do in these stages. But in all of them, there is an input-output relationship, and we will somehow make use of this relationship because machine learning basics depends on this relationship. If somehow for certain inputs, if it produce some certain output, then it tries to reveal this kind of relation and try to generate a model. And according to this generated model, the future predictions is done by the machine learning algorithms. So we will discuss all of them, each of them one by one. And let's start with the first one, which is the test case generation. First of all, after we analyze the requirements, we try to cover them by the design test cases. So what we can do is maybe we can somehow teach machines how to do that by observing the past examples. For example, I will share a concrete scenario. For an API, let's say on the slide, we can see an entity which can be sent to an endpoint of the API. For example, this is a sample entity for a library API. And let's consider that we have some get or post endpoints, and we can get the books which were stored in this library, or we can add some new books whenever we register some new ones. So we can make some post queries, or we can get to reach to the all the list that are already present in this library. So what we can observe from this data or from these requests or the responses is in all these book entities, there are some different fields. Like the book information is stored over the ISBN field. Every book has a unique ISBN number. And every book has a price, of course, and each one was published in some certain year. So all this information is kept on these fields. And what we can see, what else we can see is these values are kept with some different data types. Like, for example, ISBN number is a string value, maybe in some certain format, like 1 character and the dash character and some 3 more characters, and in a certain format. So we can observe and learn all these patterns. So similarly, machine can also learn these patterns. And after realizing all this model, generating this model, then it can produce some new data. Like maybe it can inject some new data to the ISBN field and, for example, replace this string with another string and try to perform a post query. With a new ISBN number, with a new unique number, it can try to post a new book value into the API. So it is already a new test case. Try to perform the post query with a new book data, or try to get some newly registered books by performing the get query. Or it can also perform some negative test scenarios as well. For example, instead of injecting some string values, maybe it can inject some unexpected data types. Like it can inject a negative value in the price field. Then all these are some newly designed test cases by the machine learning algorithms. Similarly, on the UI side, in addition to the API, we can perform some visual recognition activities, like we can try to locate the elements on the pages by trying to find them according to their images. For example, in an online shopping site, if we see an online shopping cart, we can understand that it stands for the shopping basket. So if we add some items in our cart, then they will be filled by the items. So these kind of actions can be revealed by the machine learning algorithms, and these different test scenarios can be generated by these algorithms. And after we generate the test cases, the next thing that we do is to implement these codes. And for implementation, again, the relationship between the input and output values can be revealed. Like, for example, for this input list, if I get a certain output, then what kind of calculations is done? Maybe the input list is multiplied by 2, and then maybe the list is sorted starting from the smallest value to the biggest one. So this kind of calculations is revealed, and the needed code is injected by the machine learning algorithm. On the other hand, for UI automation, it is most of you will be agreeing to this. Sometimes UI automation is tricky because trying to locate the elements on the pages is not straightforward. Sometimes we mostly try to locate them by some maybe expat selectors or maybe CSS selectors, or if they have the ID, we try to put some IDs, but they can be changing in time. Sometimes developers change them. So what we can do instead is, instead of trying to locate the elements by their selectors or locators, again, maybe we can collect all the items or all the elements on the page and try to predict which one is the one that we are looking for. Maybe, for example, if we are searching for a search button, we can already have some lots of images which were taught to the machine that, like, this image can be a search button. And if we can all imagine that how a search should look like, right? It may be some image like the mirror or something else, or we could all imagine how a play button should be. So all these observations from the past samples and past experiences can be shared with the machine learning algorithms, and in this way, it can try to match the element which fits to our expectations in the best way. And finally, after we implement our test code, we execute them. And what we can do during these executions is we can collect lots of different data from these executions. For example, again, going over the duration example, if I'm concentrated on the execution duration, maybe I can collect all this data. For example, I perform my first execution and let's say it took 15 seconds. And in the second run, the same test case took, let's say, 20 seconds. So after some time, I will have an expected value for this execution duration. Let's say the average value was 15 seconds. So this is my expectation. From my past experience, I expect this test case to take around 15 seconds, maybe 13, maybe 16, but something around 15 seconds. So what I can decide is if in some of the execution, if it took like 1 minute, then I can understand something went wrong in that specific execution because it was not in the expected range. So I can already be warned by the machine learning algorithm. It can detect that this execution went outside the scope of the expected range. So it can already send an alarm to me. So instead of checking all executions one by one manually, I can let machine learning algorithms run on the pipeline, and it can reveal the ones which took some time other than the expected time. And finally, the last stage in our software testing lifecycle is the maintenance stage, in which we perform our code review activities or the refactoring activities. So again, the idea here is to somehow teach the best practices to the machine. Like if I somehow teach machine how to do the code review, then it can do instead of doing it manually. Like if I teach somehow having some magical numbers in the code is not a best practice, it's an anti-pattern, then if I have a magical number in my code, then the machine can warn me. You teach me that having some magical numbers in the code is not a best practice, but now I can see that you have some numbers I cannot understand for what it stands. So please refactor this. It can already perform this kind of code review activities. So instead of losing some time, instead of having some waste of time to try to do that manually, we can already run the code review activities by the help of machine learning algorithms. So I'm closing to the end of presentation. So let's remember what we have discussed throughout the whole talk. We observed lots of different transformations that we are applying in our life cycles and the processes. For example, we already replaced our manual activities mostly with the automation activities. We are trying to automate our test cases. And on the other hand, instead of having the waterfall approaches, we already try to apply agile approaches, like we are trying to have minimum viable products at the end of each sprint. And finally, instead of the big releases, we are continuously testing our products, our systems under test. All of these have, of course, a lot of big advantages, but on the other hand, all of them has raised some new challenges for us. So to cope with these new challenges, maybe we can adapt machine learning algorithms in our each software testing stages, starting from the early stage, like to develop our test cases, maybe we can get help from machine learning algorithms to design new test cases. Instead of trying to do manually, maybe we can already let them do for us. And to implement the code, we can already adapt machine learning algorithms, or for the executions, we can let them collect lots of different information. And from all these observations, all these learnings, all these past experiences, it can make some future predictions as well. So somehow, if we are able to adapt them in our processes, we can perform our quality activities in a more efficient and maybe more consistent way. So thanks a lot for listening to me, and I guess we have still some time to go over the questions. So if you have any questions, please do not hesitate to raise them.
Okay, Mesut, fantastic presentation. What I liked about that presentation was you hear these days that machine learning, AI machine learning is the next thing that's going to replace software testers. I like your presentation because you said we as software testers in this situation we're now in really need some help, and these tools can help us. I think that's a fantastic and very positive take on this current trend to use more machine learning. And also from my point of view, thanks for those 2 slides about the history of software testing. I've been looking for that information for a long time, so I now know where to look, so that's good. Okay, we've got a few questions. Quickly we'll go through them. Just a second. Share my screen. Hopefully you can see it now. So the first question from Ferro is, are you using machine learning in your daily testing activities? If yes, what for?
Mm-hmm. Yeah, actually, I tried to make an analysis on the bugs that we have with the help of machine learning. I tried to classify them according to the priority levels, because, you know, the bug triage is very important. We have to decide about the priorities of the bugs. So whenever I'm deciding about the priority of a bug, normally how I'm doing, I'm just making my own judgment. But maybe it is not consistent with the others. For me, it is like 72, but for you, maybe it is 74. So it depends on the person. But if we do this with the help of machine learning algorithms, it may be more consistent, because machine can review all the bugs, all the issues, and then make a prediction according to all these past samples. So I tried this and tried to classify the bugs according to their priority levels, and I checked the results.
What you were explaining. So you did the defect analysis, and were you able to get some good results out of that? I'd be quite interested.
I was just explaining that. I checked the results with the reference. The reference for me was the priority levels, which was set by the human beings. So the result was around 80% accuracy. So I think it can be accepted as successful, because it was a challenging one. Because again, deciding about the priority levels of the bugs is not straightforward. It may depend on the situation, or it may be subjective. But after this, I had around 70% accuracy.
Okay, great. Okay, and just got time for just one more question. Is the testing future only about test automation? It looks for me as there were too many technicalities. Or let's say,
I may say that the test automation is maybe the focus and the point that we are concentrating on mostly. But of course, there will be always some manual testing activities as well. Even if we automate everything, still we need the manual automation, because sometimes it is not possible to automate at all. For example, currently I'm working in the robotics industry, so we are testing in real robots. So sometimes it is not possible to automate hardware-related cases. But even if we automate, it is not same as running in the real production environment. So eventually, even if we perform 100% automation, we will still need some manual activities as well.
I agree. I think manual testing will never disappear, because I don't think machines can ever really replace human. I don't know the psychological word, but our ability to see things and understand the context of things. But automation can help us a lot. Okay, Mesut, thank you very much for your presentation. It's been a pleasure having you again on Tesena Fest, and I hope next year we'll see you again, and maybe next year we'll see each other in person sometime.
I hope so. Thank you so much. It was my pleasure.
Thank you. Okay, so we move away from a star of Tesena Fest past and present, and we're moving over now to a local star. It's Filip Šátek, who's from Seznam CZ. Seznam CZ is like the Google of the Czech Republic. I would maybe say it's a local language or the localized search engine. Also a new server, and I think everybody in the Czech Republic is familiar with it and uses it on a daily basis. So Filip is here to talk about the challenges in Seznam CZ, and he's going to talk about autonomous testing, which is a really new trend or a subject that's coming up more and more often. So it's the latest trend in software testing, and Filip's going to explain us something about it. So Filip, if you'd like to
I will share the screen.
Your presentation, yeah.
Okay, can you see me or can you hear me?
Yes.
Okay, great, thank you.
Right. Hello, everyone. My name is Filip Šátek. I work as a lead QA engineer at Seznam, and I would like to talk to you about autonomous testing. More specifically, about how and especially why did we build our own autonomous testing tool for websites. At Seznam, when we are building new products, we are always trying to do this with test automation in mind. We are working in an agile environment, so quick feedback of application health is always very important for us. We are trying to follow best testing practices by having a larger amount of unit tests to test application logic at the lowest level, some integration tests to test the application as a whole, and just a few end-to-end tests to test some real user scenarios. We also have some different tests to test, for example, performance or the visual side of the application. A must-have thing has always been to have the tests as part of our continuous integration pipelines, preferably running with each code change. Without this, the tests were getting broken all the time, and they didn't provide reliable feedback. Even though this seemed like a reliable setup, monitoring still proves to be one of the most important parts of our setup, serving as our final defense. Well, if monitoring revealed some bug, it meant that we were not able to stop it before deployment to production. But at least we were able to react to this and stop it sooner than most users noticed that anything went wrong. So we could roll back the application or release a quick hotfix. But it still meant that we actually released some bug into production environment, which shouldn't happen. So we were wondering about how to improve our setup. And we came up with an idea of a smoke test, where we would perform some random user-like actions on the website and see if the site crashed or survived. And that's how we came across Gremlins.js. Gremlins.js is an open source framework which can release a horde of undisciplined gremlins upon your website. At least it says something like this in the README. They click all over the page, try to write some stuff into input fields, and do some other actions trying to break down the website. This seemed exactly like something we wanted. Some tool that will do some crazy actions and give us a quick feedback about the application health. So we decided to actually implement this. Since gremlins are actually just a script that has to be executed as part of the website, we decided to use Puppeteer to run the script. And since we are always trying to run all tests automatically as part of our pipelines, we created a continuous integration job where this test ran in a headless mode. This seemed simple enough, but soon we ran into some issues. First being that the navigation interrupted the test run. This was because gremlins ran just in the page context. This wouldn't be that much of a problem for us because our applications are actually single page applications. The bigger problem was that gremlins were actually clicking on advertisements on the website. This was a serious problem. So it can be a nice way to make some money, but our advertisement partners probably wouldn't be very happy about this. Another problem was that gremlins showed what error happened, but they didn't provide that much information. They didn't say where it happened or what steps led to this error. And since JavaScript can have some very friendly error messages like cannot read property X of undefined, it can be sometimes really difficult to find what happened, especially if you don't even know if it happened on the home page or some other page they have gotten into. So a really big problem was that nobody, not even gremlins, knew what they were doing. And this led us to a question. Is there a better way to do this? And how can we actually solve these issues? Well, the obvious thing to do was to actually start understanding the website, to interact with actual elements, not just random window coordinations, to see what can we do with them. And just by this, we can start dealing with all the other issues. And since we couldn't really accomplish this with Gremlins.js, we started to put together some ideas for a new testing tool of our own. First requirement being to stay alive through navigation. This seems obvious, but it is also very important. And it can be easily solved just by using any of the popular end-to-end testing tools. We decided to go with Puppeteer since we already had some experience with it, and it also provided some really nice features we could use. Next requirement is to interact with specific elements. And for starters, we decided to implement some click action and some type action to write a text into inputs. Selecting the proper elements is also not so hard in the end. We put together a piece of logic which would select from DOM only visible and interactable elements, which did not have any child elements. And just like this, we were able to accomplish this requirement. And also, by actually understanding the website elements, we could stop interactions with elements we wanted to keep intact, like the advertisements. Define what is bug. This was also very important for us, since our websites are running some third-party scripts, which are throwing some errors from time to time, but they don't actually affect the functionality of the website. That's why we wanted to implement a way to ignore these errors. And since our single-page applications implemented their own error handler, we wanted to listen to this error handler instead of the default window on error. So we would be dealing only with errors actually affecting our application. Reduce steps to reproduce the bug. We are thinking that the first thing anyone will do when the test found an error and showed 100 steps preceding this error, users would start trying the last action that happened to see if the bug can be reproduced. And if so, then try to find some minimal number of steps leading to this bug. And since this can be actually easily done automatically, we decided to implement this right away. And one final question. We are trying to decide what is the best way to show the test results. Reading the console log, which shows some long selectors which should be interacted with on the page, well, it didn't seem very user-friendly. And since we already have a tool that can play these actions, we decided that the best way might be to actually replay these steps leading to a bug in a browser headful mode. And we also added some highlighting to the elements we interacted with. So in the end, you can relax and watch what is happening. Now you can watch what is happening. We will start the test run, which will try to identify some errors on the page. And if this process was successful, we will play the scenario in a preview mode. Just like this. So now that we have built and tested the prototype against some dummy websites, it was time to try it against some real, more complex web pages. So we tried to run it against one of our production web applications. And after a few minutes, QA was already alerting us about some issue. It seemed quite impossible since this is actually our production website. It shouldn't have any obvious bugs. Monitoring didn't show anything out of ordinary, and we also have such a nice testing infrastructure which shouldn't let in any bugs, especially bugs which could be reproduced in few minutes. And according to QA, all that was needed were 2 convenient clicks. And that's actually how QA showed its worth the very first day. We ran QA in preview mode to show us the bug, and was actually able to crash the whole website by doing 2 simple interactions. Luckily, this wasn't very common user scenario. That's why it wasn't showing up in the monitoring, but still, the website cannot crash just like this. So this is how QA found its first bug in production environment, and at this point, QA wasn't even production ready. Let's take a look how QA works under the hood. QA is composed out of 3 key parts: scriptwriter, tester, and reporter. Scriptwriter generates test scenarios, which are sent to tester. We have 3 kinds of scenarios. Random scenario, doing some random actions on the website and trying to find an error. If successful, it will trigger a failing scenario, which tries to reproduce the bug and find minimal number of steps leading to this bug. Again, if successful, it outputs a prescription which can be later used by a user-defined scenario. User-defined scenario replace scenarios leading to some of the already found bugs. This is used in preview mode, or when you want to retest some of the already found bugs. Tester runs its own instance of Chrome. There can be multiple testers running as part of a single QA test run. It receives scenario from scriptwriter and performs the actions prescribed in the scenario. Both scriptwriter and tester are informing a reporter about everything they do. Reporter is used for logging and distributes all the information it gets to all the registered reporters. Let's take a look at default QA lifecycle. It starts by running a test scenario. It can be either a random or a user-defined scenario. And it tries to find a bug. If successful, it tries to reproduce this bug and also tries to find minimal scenario leading to this bug. And again, if successful, it will report the bug, and it doesn't have to be necessarily console output. A bug report can even mean creating a GitHub issue or issue in any bug tracking tool. When you look at this lifecycle, it is pretty much the same way a manual tester works. It starts with running a test scenario, and if he finds a bug, he will try to reproduce it and find some minimal steps leading to this bug. And again, if successful, he will report the bug describing the exact steps leading to it. So QA is actually trying to work the very same way a manual tester would. Now let's take a look at how the actions work. QA will try to find all interactable elements on the website before every action. And it will check what actions can be performed against each of the elements. So you can see that click is available against pretty much any element on the page. And there is only a single type action which can be run only against the text input. QA will gather a list of all possible actions against all elements, and when running a random scenario, it will pick randomly one of these actions. And this mapping is redone before performing any action. This leads us to custom actions. Custom actions are a very powerful feature which can improve QA performance. It allows you to define a custom action which might be specific for your website. And you shouldn't be limiting yourself with a simple click or filling a single input. An action can actually be even login or filling out the whole form for user registration. You can think of this as some sort of sub-scenario. These actions can be implemented by defining 3 methods for action lifecycle. First being a check. If an action should be available for the current page or an element. In case of login action, this could be a check if the login button is available on the page. Then perform the web interaction. Here, you can use Puppeteer interface to make any interactions needed to complete your action. So you can, for example, in case of login, fill out the login form. And in the end, evaluate the results. So you can check if your action, like login, was actually successful. Here are some more features which can be really useful. A regression test is generated for each bug. This is so important and so useful. By this, we are actually using a test-driven development in the process. We have a test which discovers a bug, and once the bug is fixed, this test serves as a regression test, so the same mistake won't happen again, and it's effortless. Another thing is that you can define custom reporters. This is, again, very useful, especially in case that you are running QA against production environment. It can create issues directly into your bug tracking tool instead of just some console output. Another simple but very powerful feature is an ability to define multiple starting URL paths. If your website has many different pages, this can seriously help you to improve the test coverage. Imagine we were running QA only against the home page, but there are also pages which require like 5 clicks to get to. It could take QA some time and actually also some luck to actually get to these pages, and the test coverage for these pages compared to the home page would be minimal. But by actually defining multiple starting points for QA, you can raise this coverage so much. And one more very useful feature is an option to define before and after scripts on multiple places for the QA test run. This is useful for pages requiring some login to gain access, like administration sites. And now let's see, how do we use QA at Tesena? We have 2 use cases for QA. First, being part of our continuous integration pipelines and running with each commit any developer pushes into the Git repository. This works as the smoke test. This works as the smoke test we wanted to do using Gremlins.js. This test runs just few short minutes and provides a quick feedback about application health. The second use case is that we deployed QA into our cloud infrastructure, where it runs against all our production sites 24/7. It tries to find some bugs all day and all night and never gets tired. Whenever it finds a bug, it creates an issue in our GitLab for the specific project. So when the developer comes to work, he or she can work on it right away. This has been very useful for us since our websites are dynamic. We can change them from administration, or we can add some new content to them. So with some bad luck, something can break down even without having to release a new version of the website. So it is very useful to have a tester checking our websites all the time and providing us with some feedback. And what do we plan in the future? We would like to implement an option to generate scenarios based on analytics data. This can help QA to actually test some real user scenarios instead of doing just some random actions, and it can seriously empower its performance. With test coverage, we could tell QA to reduce the chance of doing the same actions again and again. So in the end, it will be doing more unique interactions and raising the test coverage at lower computation time. Even though we are quite happy with the preview mode that already comes with QA and which can be used by a programmer to rerun the failing scenario, it is not so useful when some non-programmer like product manager comes across this bug report and tries to see what is happening. A video recording in this case would be so much better, so we would really like to implement this feature. Web user interface could be also very useful for long-term QA runs, like the cloud deployment we have in our company. It could allow us to see the progress, check all the bugs that have been found, and manage regression tests generated by these bug discoveries. It could also inform us about some flakiness in these saved scenarios and implement an ability to fix these test scenarios or remove them completely. So to sum this up, why should you use autonomous testing for your project? The most important point, the test scenarios or user stories are generated automatically. So you don't have to write any tests. All you have to do is to review the results. And now, this is quite important. Test coverage is actually a question of computation power. The more computation power you give to your autonomous testing tool, the more results you get. This is such a key difference compared to test automation, where more computation power can only reduce the test runtime, but it won't provide you with some new feedback. And one more very nice benefit is that it requires minimal maintenance. Once the setup is complete, everything is generated automatically, and you only need to review the results. So let's ask a question. Can test automation be actually replaced by autonomous testing? Well, from my perspective, not really. Test automation targets some different issues than autonomous testing. And test automation is not just end-to-end tests. There are many lower-level tests which can be very powerful and can provide much clearer feedback and also much sooner. And even with end-to-end tests for autonomous testing, it could be taking so much computation power to actually test all the scenarios. When in reality, there are some key user scenarios which you want to test. And with test automation, you can do it way more efficiently. So in the end, I think that actually combination of test automation and autonomous testing is the right way, at least right now. What can be quite interesting is actually adding some of the test automation into autonomous testing. By this, I mean the custom actions I've talked about. You can actually transform most of the end-to-end tests to be playable by autonomous testing tool at any point. So you can make sure that your key user scenarios are always working in some different situations that you didn't anticipate in your end-to-end test scenario. Well, and this is all from me. Thank you all for coming. I hope that you enjoyed this presentation. And now we have some time for questions. Thank you very much.
Okay, Filip, thank you very much. It's fascinating, a little bit scary, in fact, I think. Just to repeat, this is open source, right? This tool.
Yeah, this is open source.
Right, that's great. And the second question, my first question, because I can jump to the head of the list because I'm moderating. Did you see an improvement of in the monitoring, that you're getting less production errors by using the tool?
And I don't think so, actually. the setup that we have that runs the tests like permanently against our production websites. It finds 1 or 2 bugs every week, and it's like this constantly since it started running. I think it's been like a year since QApe is running against our production websites, and it's still pretty much the same.
Right, okay. Okay, thanks. So the first question from Michal is, why Puppeteer and not Cypress.io or Playwright? Why did you decide to use Puppeteer?
Yeah, at the point when we were creating QApe, Playwright wasn't existing actually, or maybe it was really in the beginning, because QApe was initially created like 2 years ago. So Playwright at that point, I think it wasn't really an option. And Cypress, it seems like I don't know. It didn't seem like the proper tool we wanted. Since Puppeteer is actually like just a tool to communicate with browser and use all the powers of the browser, it seemed like a better option than Cypress, which is implementing so much more. It has its own test runner. And it also has some limits, since, for example, Cypress cannot run multiple windows at the same time. It's not like a feature we needed at some point, but maybe in the future it might be useful. And since it had these limitations, we wanted to use Puppeteer since it should be implementing all the features we need for a browser, and it shouldn't limit us with anything. It was just doing what we needed and nothing else, and nothing less, nothing more.
Okay. I just want to add: are you following the discussion, or the Playwright guys are now saying that Puppeteer is a dead product?
Oh yeah,
and Playwright is the future. You're following those conversations. Do you have an opinion about that?
I'm not really following the conversations, but we actually tried Playwright in our company, and we used to use Puppeteer. But Playwright, we are right now migrating to Playwright because it has such nicer debugging tools, especially the debugging tools. And I'm thinking to try Playwright with QApe, because the switch shouldn't be that hard actually. But we'll see how it goes.
Right, interesting. Okay, thanks. The next question from Marosh: how long did it take you to implement this solution tool?
Well, like the first prototype, it took like a week or maybe 2 weeks to actually try this concept, like if it's gonna work or not. But it took so much time to actually optimize it for so many situations, because whenever we ran it against a new website, it would show us some new problems that this specific website had. And we wanted this tool to be actually universal for any kind of website. So I think QApe has been created about 2 years ago, maybe even more, and we've been trying to optimize it since then, and from time to time implement some new features.
Okay, so you're still actively trying to improve it.
But it's already doing its work, so it didn't have that much focus. But I hope we'll get to it soon.
Right. Okay. And since it's open source, I guess you're hoping that some other people might join.
Yeah. Already, you people from Tesena are joining, so that's really great. Thank you for that.
All right. Again, hopefully, because of this presentation today, I hope more people would get involved. Okay. So the next question from Marosh: how do you measure that QApe is successful, helpful, and produce relevant information? So,
well, we are not really showing the irrelevant information with QApe. Like QApe internally has 2 kinds of errors. It can be the execution error, and it can be an error on the website. So whenever a QApe fails for some reason to actually run as it should, like it runs into some unexpected situation that he doesn't know what's happening at that point, we are in debug mode, you would see this information, but in normal run, we are just skipping this and providing just the useful information. So only whenever QA finds a bug, it will be reported. Otherwise, it's since there is so much information that can be showed, we are actually trying to show just the information that's only needed. Because if we actually showed what's happening on the website, it would be such a crazy logging. Saving this only for the debug mode.
Okay. I think Marish is also asking, you're finding these bugs, yeah, with QA, and the developers are happy because these are sort of bugs that you weren't finding before. And
well, I guess they are not that happy that we are finding some bugs, but we are reviewing the bugs, and since it's sometimes it's some rare use case, so they are not very happy, especially about these. Still, it's nice that we know about these bugs, and I hope that it makes developers at least a little bit happy.
Yeah. Okay, thank you. And the next question from David. Hi, David. If you compare autonomous and automated testing, which approach is more efficient in finding bugs?
That's really hard to say.
I have my answer.
By the time, since we are actually using a lot of test automation, the bugs that are coming to production, I hope that there is only the minimum amount.
Yeah.
So when we are running this tool, there shouldn't be any bugs. So right now, test automation is stopping more bugs before coming to production environment. But the autonomous testing also is finding some bugs that we didn't catch earlier.
Yeah. And just for context, how many automated test cases do you run for each release?
That's really hard to say because we have some complicated setups. It could be like hundreds or thousands of unit tests, some maybe lower hundreds of integration tests, and just few end-to-end tests. It's not that much.
But quite a big test suite.
Many levels. We have some modular system, so it's kind of on different levels. There are different tests. It's a bit more complicated.
And I'm just answering, adding a question from the previous presentation. You also do manual testing?
Yeah, especially every time something is released to production, like some quick check, we always do some quick check, but we don't have some test scenarios for manual testing actually in our company. We are just hoping that our test automation is good enough. And as I said, we have the monitoring, which is usually providing us with quick feedback. If something went really wrong, we would just see it right away after the deployment, and we can, in a matter of seconds or minutes, roll the application.
Okay, thank you. And the last question we have here from Peter. I'm sorry, but I overheard how QApe, I think misheard or didn't understand, how QApe recognizes that the next page is the correct one or will not end up with a timeout.
I hope I understand this correctly, but whenever QApe leaves the page he's testing, we have just some really simple logic for this, that it checks if it checks the current host, and if it leaves the current host that was defined in the beginning, it will just get back by actually touching clicking the back button. It will get back to the original website. So that's how it works. It's not this here is definitely room for improvement, but this was enough for us so far.
Okay, so that's the last question. Filip, thank you very much for your presentation. I think that's the first time I've heard a lot about autonomous testing, but that's the first time I saw something happening. So for me, it was interesting to see that this sort of approach is real, and people are already working on it, especially in our local market. So that was fascinating. So thank you very much.
Okay, thank you.
Thank you. Final presentation of the final day of this year's Tesena Fest. At this moment, I usually have to promote what's coming up next week, but there is no next week, and talk about workshops, but they've all finished. So we're at the very, very end, and we've got the biggest star of this year's Tesena Fest. But we're really, really pleased that Kohsuke could join us. He's the creator of Jenkins, and he's going to talk about the future of testing. So Kohsuke, if you'd like to share your screen, the main stage is yours.
All right. Well, thank you very much. I think you should be seeing my
yeah, we can see it.
Slides. So, all right, let's get going. So yeah, thanks for the intro. I'm Kohsuke. So today I'm gonna make a fool of myself by talking about the future, right? Because like what can go wrong? But you know, like if you look back over, I don't know, maybe like a decade or two, clearly there is this like a the going trend in which the software development kind of continues to become more and more important, right? And then the software delivery is getting faster, but it's not getting fast enough. So every team that I talk to is under the struggle that they need to deliver faster. How can they do that? I mean, like there's an old saying that the change is the only constant, and that truly is, that is truer than ever before. So when you think about like what it takes to kind of go faster, I think the prevailing sense in my mind is actually this like a testing the quality phase that is slowing things down. Like it's relatively easy to come up with a change to the software, but what it takes time is to build enough confidence in that change to feel ready to put it in production. Right? And then so even though the quality is an age-old profession, and in some sense, like historically, it's probably more narrowly defined as like finding a defect, but it really needs to evolve. And then so that's what I've kind of been interested in lately. If you talk to, I guess, some of the web startups, or maybe actually like any young company, and this is originally Facebook's mantra, that like, it's okay, the velocity is what's important, and it's okay to break things. And that's a prevailing mindset until, they have a few embarrassing outages, like a high profile incidents. And then they realize to the reality that, oh, like we can't ignore the quality after all. And then that, like once they start taking things on, then it starts to drag things down. So if you look at more established space, regulated industry, where you can't just move fast and break things, let's say in the financial sector, you see that, they can't really move as fast as they want to. I was talking to a engineering manager in Slack, I think maybe about this time last year. And I was asking how they do, the software development and like what kind of testing they run. And the guy I was talking to very proudly said, "Oh, I can push the change in production in like 10 minutes." Right? And then there's like the only testing they are running is integration test, et cetera, et cetera. So I was really truly impressed. Wow, like you can turn around like the entire Slack deployment in 10 minutes. And here I mean, in contrast, like if I wanted to put a one-line change in Jenkins project, it's going to take one hour minimum. And then, like lo and behold, like early in this year, I think in fact the very first day of the work in this year, a Slack went down, like caused I think a 4 or so hour outages, and then like it went to the headline of all the major news. So I'm pretty sure if I go ask him the same question now, the answer is probably different. So there's just like a world is full of examples like that. And there was another web app, the mobile app. So this back in the beginning of the COVID, Japanese government, or I think maybe the government developed this software where you can like sign up, like install this app on the phone, and it keeps track of like who you are in the close proximity. And then if somebody later is diagnosed as like a COVID positive, then you can receive a notification that, hey, like you've spent like a significant time with them, so you might want to get tested yourself. And then so I think like 4 or 5 months after the launch, they made this very embarrassing press statement in which this mechanism to push out the notification to the people who were in close contact on Android, that was completely broken. So not a single soul has received any notification from the system. I mean, just like the fundamental failure of the app, and I guess, you know, to their defense, it was because of the privacy concern. This wasn't as easy as you know, like a regular old notification system, but still, I mean, that shows like an importance of QA. And if you go back a little bit even further, I mean, does anybody remember the Boeing 737 MAX? And then the software failure that led to 2 airplanes crashing within a relatively short amount of time. Another failure of security. So even, I mean, these guys know what they're doing, generally speaking. So they're, you know, they are testing like left and right and right, but that's still not enough. So yeah, so that's, I think, the, you know, as the software plays more and more mission critical role in the world, right? More and more of the social fabric depends on the software now. So as a profession, I think we have a bigger responsibility to the society, or the mankind, if you may, to up our game. So how is the testing evolving? Now, the interesting thing that I find, again, talking to different teams, is that like things are almost at the two extreme. Like on one end, on the left, lots of teams are basically suffering because they have no test or very little test to speak of. I talked about the Slack. I talked about this like a COVID-19 contact tracing app. So the example of like no testing failing altogether. And then there are the other people on the right where like, you know, there are too many tests and they're basically like, they don't know, they have a tidal wave of tests and they don't know how to deal with it. Like it slows them down so much. I talked about the Jenkins project case in which, like I mentioned, the one line change takes an hour. But in the grand scheme of things, I regularly meet people like doing far worse. Even after like everything, like they did prioritizations, they did this and that, and they have a massive hardware farm, but they and then drive like millions of the hours of testing on the software, and then it's still not, you know, and that they just can't cope with that kind of size. So that's kind of, you know, I find that interesting. Now, on the so let's start with this like a no testing side, right? So I think the one evolution that's happening is clearly to shift development more to in-house, and that's actually helping the QA. So this I was talking to this one of the, I think, the tier 1 or tier 2 part supplier to the car companies, and then they were, you know, they are developing software. So they are actually it's so the way these guys works is like, you know, they contract out the software parts of the, you know, they build these car parts, right, which contains the software, actually a significant amount of it, and they contract out the software developments to another company. And the reality is this, you know, contract is basically described in such a way that, you know, by this time, by such and such date, we deliver such and such features under this much amount of money, and that's the basic constraint, right? So when the contract is structured like that, which is very typical, then it's very difficult to invest in testing. Because if you think about it, the key motivation to do testing is to kind of pay the price up front so that, you know, let's say you can keep running those tests and make it easier to catch future regressions. And that's a general prevailing practices around CI/CD. But if, you know, contract doesn't say anything about the future, like you're only talking about the next year to deliver this feature, then there's a very little, like structurally, it's just so difficult. So he was saying, well, like, you know, my boss understands the importance of testing, so they can kind of squeeze it in this here and there to kind of get things going. But here's a clear example of like you fighting against this like a force of economy. So no wonder like they can create very little test. So that's, I think, luckily, I think with more and more company realizing that, you know, software is a more critical part of how they, you know, provide value. I see the definite trend to bring the development back into in-house, and then that aligns this like a long-term incentive properly. So that is an encouraging change. Another sort of important trend is this testability getting baked into the software design itself. So, when I began my professional career, it was the QA and, at Sun Microsystems, the QA and engineering was sort of basically almost intentionally designed as two separate organizations with a little bit of tension. And then the thinking is like we have to make sure that the engineers are not slacking off or not cutting the corners. So the QA guys are supposed to find those. So natural tension was actually almost supposed to be helpful. But the flip side of it is, the engineers produce things with testability not that much in mind. So the act of testing gets harder. And I think you can still see some of those today, like, the reason the mobile testing or the web browser testing is harder is like, when you're dealing with the software from like an external interface, it's surprisingly difficult to get the good testing done. So as the QA and engineering, like a software development kind of evolved into like a one profession, like a one work, then it became more sensible to essentially design the software with the testability at the heart. So I was particularly impressed by this one blog post from Airbnb Engineering. They were developing Android mobile app. So they eventually developed the entire mobile app development framework with one of the key goals being testability, so that it removes any sort of a root of the flakiness. It's incredible. They make it very easy to insert arbitrary data as the mock data, and then render the UI without any asynchrony baked into the process. So that really made things better. So that is a prime example that when you take the testability seriously as a software engineering practice, then you can push up the testing to a whole new level. And then obviously another evolution that's helping this low to no testing guys is more automations. Right? I mean, and this is where I have been spending the past 15, 20 years at this point, right? Pushing more automation in the software development, and still tons of people doing that. I mean, it is hard. And then I see a lot of low code, no code test scripting, some machine learning assisted scriptless testing. There's clearly a space for innovations in here. I mean, even some a decent parallel testing is still too difficult for many. I think the test frameworks and build tools that drive them are still generally written for the era of the a decade or two ago, where the build and testing was seen essentially as a single machine activity. So yeah, so I guess enough people probably talked about that part. So I'm just gonna I'm just going to leave the automation part to the other capable speakers. I guess another kind of key trend is I started this presentation by showing this infinity. So if you think of this a recurring, repeated testing happening rapidly, then there's clearly a shift from this mindset where it used to be that the QA was seen as a gate. The software is produced, and the QA's job is to kind of work on it and eventually to produce one bit of answer, which is a pass or fail. And if you're pass, then the software is good, and then it's allowed to proceed. And then if it's failed, it gets rejected, and you have to make additional code changes until it passes. In the world of continuous delivery, I think there's a more evolvement from that kind of mindset, the gate, into more defense in depth. So it's no longer a single gate, but there's this numerous, well, probably not as many as this picture implies, but multiple layers. So basically accepting the fact that there's always some risk in software development, even after you test things. And then instead, or in addition to testing, you do some precautions to make sure that when bad things happen, which inevitably will happen, then like try to contain those, mitigate those, bring it quickly back to some functioning state, and basically like to make sure that a single fire in one apartment, one room in the apartment doesn't bring down the whole apartment. So this kind of like compartmentalization of failure, I think, is more and more prevailing mindset in the software engineering. So I think that is also evolution of testing. It's no longer just something that produces a binary answer. It becomes more like a process-wide thing. So, the feature flags, it's a mechanism to, to decide some like a less tested, less confident features out there, right? And expose it in a limited fashion also allows you to cut that off quickly without redeployment. Circuit breakers, another mechanism to make sure like if one part of the system is dead or misbehaving, then you can rapidly cut that off from the system and make sure that the rest of it will function in some degraded state. So I don't think previously these things were seen as the QA, or the testing, but I really do think like in the 2020s, those are like a key evolved form of QA. So it became more and more integral part of the software engineering with emerging practices like that. So now if I switch the gear a little bit, then, so I talked enough about this like a low to no testing guys. Now, the other extreme challenge, the other end of the spectrum, like I mentioned, is like a people with too many tests. I mean, if you go to any successful projects that's been running, I don't know, like 5 years, 10 years, it's very common to see like they have amassed so many tests from the entire history of the project, like many of which people who are left behind have no idea what these tests are for. But because it's there, they're gonna run it because everybody is feeling naked about the quality. So what are they doing? Because like as I mentioned, when you have tests grows so quickly in volumes, basically like as the longer the project exists, the more test gets written, right? And also the amount of tests being run is proportional to the active development that's going on. So in reality, like the test workload grows more like square or the cubic to the something like a scope of the project or the size of the project. So at some point, like the things that happen, the automation gets like just so much, and that the data that comes out from that automation becomes so much that it becomes untenable. So that's, I think, the challenges of this like a too many testing program. And there, the key trend that I'm seeing is this, like emphasis on data to drive DevOps. And those are the common traits, I think, among people who are really taming this beast. So it's one good example is when the scale of testing, the frequency of tests was small, or like it used to be, humans' job to go look at the failures and make sense of what happened. Right? And I remember at some microsystems, we had a dedicated person whose job is to keep track of like which failures are being observed in the QA, which ones are being currently worked on by developers. So and here's a ticket and here's that status. And then this is a new failure that needs to be investigated. Oh, this is a failure that needs updating in the test suite. So there's like a keeping track of what this data means was something that the human used to do. With the frequency going up, like that's really not possible to be done by humans. We somewhat side-skirted that problem by shifting more tests to the left. So the reason you need to do this kind of traffic copying is because everybody's changes are landing into the same place, same test execution. So you needed to triage them. If you're pushing the gate to the left, and then only testing individuals change, then it's obvious who is responsible for the failures. So that was kind of how we, they kept it at bay, but it's really not gonna, survive very long because that's gonna balloon the test workload. So at scale, that kind of practice simply breaks down. you just have so many tests, so many developers running so many changes that it's just not practical to run everybody's changes independently. Test everybody's changes independently. So what these guys are doing now, the one practice that these guys are doing that I got my attention really was this idea of predictive test selection. So if you think about it, that as the speed of delivery goes up, the increment of the change from one test session to the next becomes smaller. So it starts to make sense that to focus on that delta, and it's a little bit like looking at the movie, like a film, right? If you compare the two images adjacent to each other, they really don't change all that much. Like, because after all, they're like a 24 frame per second or something. So, and then you already know that the previous frame, the last state of the software was good. So if you can focus on what has changed, then can you use that information to reduce the amount of testing that runs? And that's essentially the idea of like an increment, like a focus on the delta. And the beauty of this approach is like you can, if you go from 24 frames per second to, let's say, 48 frames per second, then you can expect that the delta gets half, right? So you can increase the velocity. Obviously, nothing will work like this linearly beautifully, but the general idea is you can increase the velocity without suffering the test coverages or the quality assurance process. So there's a very interesting paper that came out of Facebook, I think in 2018, where these guys originally were doing this kind of incremental test analysis by looking at the static dependency tree of the software base. So if you look at these large scale software build tool like Basel or Pants or the back or something, they all focus on this building a very elaborate fine level dependency graph so that whenever something changes, you know exactly what needs to be retested. But and even with that, and like they went, the workflow kind of went out of control. So what they did was they brought out the machine learning so that they looked at what has changed in the source tree, who has made changes, etc., and then use the power of the AI to try to figure out what are the more meaningful subsets of the tests to run. And they reported some very even though their algorithm was relatively simple, because at Facebook, like most machine learning data scientist guys are deployed to make you click the cat pictures more effectively and not to help the software development process. But even some rudimentary algorithms that they deploy, they're able to gain a massive speed up. I think something like a half the infrastructure cost to run the test, and they only miss like a 0.5% of regression or something like that. So so that got me really interested. The idea is really simple. And I think intuitively this should make sense, right? I mean, if you have a large system and if you're making a small change, then not all tests are probably equally relevant. So if you can make some estimate, some reasonable guess, better than random guess that, okay, these tests are more likely to fail when you change that part, then instead of running testing, let's say in this case, like a random, a predetermined order, what if you can run the tests from more highly likely, tests that will highly likely fail first. And then that way, as a developer, you can get a feedback a lot more quickly. As I mentioned, in Jenkins project, it takes a whole hour to run the test, even if I'm making a one-liner. If I can get the first failure in the first 15 minutes, then that would let me immediately work on my fix. So that's incredibly valuable, right? And then you can take it one step further from the infrastructure guide's perspective. You could say there's actually no point in running all the tests. Let's just skip running these a low probability failure tests. These tests are unlikely to reveal any useful signals, so we can skip them. And while the idea of skipping tests might feel scary, remember this: we're just talking about a part of the overall funnel. Let's say pre-merge. Right, so my goal is our goal is to get the developer learn the changes relatively quickly, and then in the post-merge, for example, you can be still running all the tests to catch those additional regressions. And that's generally how you design the funnel, right? You're closer to the developer, you make the feedback cycle is more important, and closer to the right, you can have more expensive tests that are less likely to catch problems. And then, so that's how you balance them. So so this is something like I'm working. This is my newfound passion at Launchable, which is the company I started after leaving Cloudbees, and I'm building that this into the system at the moment. I'm trying to democratize some of these things that the Facebook and Googles have done on their own, and make it available in the hands of the rest of us. So that's one example of like using data to drive the push the state of the art in the testing. Another, I think, area where the data is similarly applied to solve the very familiar problem is in the area of the flakiness. Again, every software development team had some level of flakiness. And then if you look at, when I look at like what's being done in this space to tackle this problem, there is like I find like three pieces to it. Right? The one is the keeping builds green, like the key motivation for that delivery pipeline is not to let the flakiness disrupt the orderly flow of changes. So obviously, like a first order business is to make sure that the flakiness doesn't suddenly stop the delivery pipeline, like a reduce that impact. So I call that keeping builds green. There are people doing reruns and stuff like that. But if you just keep build green, then you end up masking flakiness, and that's not good. And then because at some point, if you remain uncontrolled, unchecked, it's just going to grow and grow until you cannot really keep build green. So another key integral part of it is measuring flakiness. And previously, people have been relying on just how let's see, I don't know what the right word is, but when the flakiness is fading your delivery pipeline from time to time, then you use that as a proxy of measuring how flaky things are, but it's a poor way of measuring things. So now that you're keeping builds green, like how can you measure flakiness more effectively? There's a lot of efforts done in there. And then finally, what you will find after measuring flakiness is that you have to escalate some of the worst flakiness to the developers so that they can fix them. And here, I think too many of us thought naively that perhaps by just measuring flakiness, it's enough to convince the engineers and more importantly, engineering managers that fixing those is worth their time. But if that is the case, then the world, the world is already devoid of the flakiness problem, right? Like everybody that I know is frustrated that, yeah, we have a flakiness, but the business doesn't want us to spend solving these problems, so they a bitch and moan. So when I look at, again, some of these a more sophisticated software development practices that relies on data, here's one example what the companies, I think this one is also Facebook, doing to measure flakiness. So they built this simple statistical model. So if the test is run, let's say, there is some chance that the code was bad, that leads to a failure. Or in other case, the code was good, but this test case has inherent flakiness. So with certain probability, you see a failure. And these two things aren't distinguishable from outside. They both show up as a failure. They just came from a different internal process. This is a good failure because the test is doing what it's supposed to do, but this is a bad failure. It's otherwise known as a flaky failure. So what these guys have done, but if you just look at the, observe how the test has behaved. So on the x-axis, they show different builds, and on y-axis, they stack, for example, if they run the same test 3 times against the same code, they stack things up. So from this observation, you can apply this a relatively simple statistical process called the Bayesian inference to try to estimate, if these two hidden parameter, PD and PF. So in this case, like what we suspected. Oh, like this looks like a flake here and here. So as a human, like looking at this, like we think, okay, there's some some pretty good flakiness or pretty bad flakiness in there. And sure enough, like if you apply the Bayesian inference process, they can estimate that, okay, the about so PB these that this has about like a 5% failure rate that's caused by the bad code, and then like a 15%-ish or maybe 20%-ish caused by the flakiness. So they can statistically, or they can quantify that, oh, this is probably a relatively more flaky test. So that's an example of, again, applying data well. This kind of I think this analysis, even though I call it relatively straightforward as far as math is concerned, as a quality profession is concerned, I think this is a cutting edge practice. I haven't seen this kind of thing done in many places. I talked about the challenges of escalating the flakiness to the developers, and then to convince their engineering managers to assign time for it. So here's an example what the GitHub guys have done. Like they compute something called the impact score for every flakiness. So the system is constantly monitoring, and then they quantify information like, hey, this flakiness has impacted 142 developers and 37 deployments. So these numbers to kind of make the case that this is a important flakiness. They also report in the same post that the flakiness is uneven, meaning a small number of tests contribute a lot of flakiness. So they focus on those. And then you can see lots of additional information. Like they really try to pin it down to a specific individual who should be looking at this problem. So again, that's another way of helping people to work on it. Instead of blaming the group, you try to blame an individual, which is helpful. So that's another example. Now, these things, so as I look at more of this example, this like a data-driven DevOps in which, the data that comes out from automation is deployed successfully to make the software development even more productive. Like it kind of shaken me a little. Like I used to think, and I think a lot of software developers feel this way. That is it's like a David versus Goliath, right? If you're a small team of like elite developers who know what they're doing, then we'd like to think that we can outsmart this big, slow organizations because they spend so much time like coordinating, etc. I think that has been the view. But here, what actually seems to be happening is that these Goliath, because they are big, they can produce so much data and they can harness those data to more productivity. So it actually feels like some Goliath are actually getting faster and faster and better. So, but not all Goliaths are getting better, right? So I apologize for switching the analogy, but most large-scale software development organizations that I know of are basically getting bogged down like a donkey with so many stuff getting put on their shoulder. In some sense, like a victim of their own success, because that project has been so successful business-wise. More and more crap was piled onto them, and they are not doing, they are not harnessing, this power of the data. They are not, evolving into the future of QA. And then so they're basically trapped into molasses and moving slower. But also there are some other more like a unicorn-like organization on the software development team in which they do manage to like up the game, and they're actually going faster, like they are lighter. They can learn changes more quickly than the project of comparable size if you're a donkey kind of software development team. So that which makes me wonder, like what, where did their course split? Like how did a donkey team became donkey and unicorn team became unicorns? And that is a question kind of I ask myself in trying to talk to teams for which I don't have answer. But I'm hoping to hear from you what you thought about that. And with that, I think I'm out of the 30 minutes that I was supposed to present, so I believe the rest of the time is for QA. So thank you very much.
Okay, Kohsuke, thank you very much We've got a couple of questions on the Q&A, and maybe I'll ask a few questions myself. So the first question from Marcel, how could you apply your predictive selection when you do not have information about code changes?
Yeah, you can't. And that's really kind of my point about David and Goliath. Like, this is a kind of practice that only, well, actually, like, a little more nuanced. So the reason like a Facebook and the likes was able to do this first was because they had that data, right? So I think they use that information rather rapidly. Now that I do this launchable and like I try to apply to like a smaller team, what I found is that even a relatively naive approach is still plenty impactful. So let's say a good example is like if the failure, how is that test failing in the past? Right? Like just forget about what code changes it has been linked to. Some tests just simply never fail. Like they're either testing a part of the system that's not changing at all, or maybe they're testing things that like disappeared. So it turned out that the past, if the test has been failing more often in the past, it's usually a pretty good indication that it might fail again. So those kind of naive approach you can relatively easily apply, and it's still better than what we do today as a baseline, which is basically run every test in a random order all the time. So that's absolutely worst possible thing. So you might not be able to get that kind of reap the kind of benefit that the Facebook is getting, but nonetheless you can still plenty benefit from that plainly.
Okay, thank you. And a second question, maybe quite closely related, to make the predictive selection work, how much data do you need to collect and how much effort is required? I think for me that's kind of a key question because
right. And the thing I liked about this is like, I thought this is a very low there's a very little work you have to do to benefit from this. So if you think about it, I mean, the most people are already collecting test reports for the CI system, right? Like every test runner can produce basically this one format called the JUnit XML format. So I was able to develop a system that just basically parse that informations, and then we do the number crunching on the side, and you can feed that information back later to you, so that you can, when you run the test, you can specify the subset to run. And again, that is something most test runners are capable of doing, to let you specify the test to run. So I found that the insertion to the development software delivery pipeline is minimal. Now, in terms of how much data, I think the way you should think about this, or I think about it, is this is more like adding a new person to the team. Like, you immediately see some performance jump, but then there's a growth over time as you add more data. So it's also, so I guess we generally feel like it's 100 or 200 test sessions give like a reasonable, like a noticeable impact, but it kind of really grows from there. And then I'm also finding like some teams, it's fascinating, like comparing different teams. I don't have all the answers. That's something I'm interested in looking like. So good questions.
Yeah, because I'm like a long time as a test manager, and the bigger you are, the more data you are allowed to collect. It's the bigger in the waterfall days. The bigger the waterfall project, the better the test management tool you had, and the more data you were able to metadata on test cases, because there was lots of stakeholders who needed reports. So it was really, the job was to add metadata to test cases and to defects, so you could actually give them meaning information. Where's the system weak? Where's the risk? Where are the risks? And the smaller the project, the less data you could actually let's say collect and manipulate. So certainly that Goliath thing. But then, because you have so much data, you then became extremely slow and inflexible, because if as a waterfall project moved on, I know I'm talking about ancient history and hopefully nobody does this too much anymore, then the sort of like the risks and maybe the cause of the problems changed, and you had to change your metadata. to be able to track new things. Yeah, so it made it very hard. So are there tools that can help with this? Because with this predictive analysis, you're going to have to somehow collect metadata on code to relate it to some features, some user stories, and then you're going to have go through your test set and link those to features and user stories, at least, so you can actually link the two together. Is there some sort of tools that could help you with this?
Yeah, I mean, if I may do a shameless plug, the reason I started the new company Launchable is so that I can democratize this practice. And I see it basically like parallel to what I've done in Jenkins. Like, when I started Jenkins 15 years ago, CI systems are exactly the kind of things that this sophisticated cutting edge software development team have built in-house and then use for themselves. Right? So there's not a lot of a good, generally available solutions, which I thought was crazy. So I was able to build something generally applicable, so people can just install Jenkins and get going. So that really helped democratize this practice. And now everybody kind of takes it for table stake. I think it's the same. The next frontier of the similar, this data-driven DevOps in my mind, it's a similar phase. As a concept, it makes sense, but it's lacking. Smaller teams are lacking access to it because there is no readily available solutions.
Okay, great. And with the flakiness, that for you is the next frontier to be able to sort of analyze.
Yeah, it's to me. So to me, it's like another example. Like once you have the data, there are so many ways that you can extract values from it, and that's like when people talk about the big data, that's basically what they're saying, right? Not in the software development domain, but as a retail, etc. Like if you know enough about the customer, there's so many ways to use that information. I think it's actually true with the software development testing as well. Like we used to think like we are the one that disrupting the world by the automation and big data, but turns out that we also needs to be disrupted by the same force.
Okay, so thank you very much. That was fascinating. So thank you very much for joining us. You helped us close this 4-week conference in style, I believe. I think you're very interesting point of view, and I haven't seen that point of view before. So for me, it's very, very interesting. So thank you very much.
Thank you.
Thank you. Okay, so now for me to finally close up the conference, there are no more presentation days, there are no more workshops, but Tesena is carrying on. So we've finished our fest and now we're going to go back to our standard series of webinars. So if you want to find out what's coming up, we've got quite a lot of interesting and innovative stuff coming up. So if you go to our webpage and click on the webinars, you'll see what the program is for the winter season. I hope everybody enjoyed this conference. I hope everybody stays well. I hope we get through this winter without any major lockdown or pandemic problems. And I really, really, really look forward to having in-person conferences again next year. So thank you very much and have a good evening. Bye-bye.